Hello, class.
Hello.
How are you today? How's everybody?
Fine, how are you?
Good, good. So based on syllabus today, we plan to cover section 3.1, but we do have some left over from last Thursday, right? Yeah, awesome. Thank you, Dustin. Thank you, Carla. Yeah, so our plan today is to finish the graphs. We have a matching game to finish, right? And then we're gonna go ahead to start chapter 3, finish section 3.1 today. Okay, so bunch of graphs, right? Yeah, we have seen histogram. This is a histogram demonstrating a normal distribution. This is a histogram demonstrating a distribution skewed to the right. Yeah, this one is also a histogram. It is a skew to the left. Skew to the left is also called a negative skewed. This is a histogram displaying a uniform distribution. Those bars have similar heights, even not exactly the same, but very similar. And this is a dot plot. Dot plot is quite interesting because it is a one-dimensional graph, but it displays, shows a two-dimensional view because the height of those dots they stack on each other give you the other dimension actually. And this one is a stem leaf plot. Very obvious. Stem leaf plot has two parts. Yes, stem and leaf. This is a time series. Time series graph has very wide application in finance. Time series always have the horizontal scale as time continuous. When time goes on, when time pass by, yeah, how does the price of the stock change? How does the price of the house change? How does the unemployment rate changes, and so on. And this is a pie graph, very common. You probably see that all the time in the magazine or a website. Yeah. And this one is a bar graph. Yeah. Knowing the difference between bar graph and a histogram. In a histogram, those bars touch. There's no gap in between. But bar graphs, those bars have gaps in between. Then we use histogram when our data are quantitative. So those numbers are continuous, right? And we use bar graph when the categories are qualitative. As you can see this example, those classes, look at the horizontal scale, is group A, group B, group C, group D. They are not numbers, they are not numerical. And this one is Pareto. Sometimes we do Pareto for histogram as well. The important thing for Pareto is those bars is in a descending order. The heights of those bars. Those bars are arranged in a descending order of their heights. And this way, the graph draws your attention to the most important category, right? And this graph is a frequency polygon. Yeah, polygon, frequency polygon give us an enclosed shape with the horizontal scale. There's no gap, as you can see. It's not open. It's not a open figure. It's a closed figure. Like that. That's what I mean. It's a polygon, right? Remember what is a polygon? Has a few sides, different size, has a few sides. That is polygon. And this one, yeah, we were here on Thursday. Yeah, let's continue. This graph, what is this graph? Very interesting. Yeah, is increasing. Very obvious, right? This is an ogive. Ogive is the graph corresponding to cumulative frequency. You see that? Yeah, look at the vertical scale. You turn your head. The horizontal scale gives us the classes. First class 0 to 10, second class 11 to 20, and so on and so on. Last class 51 to 60. So horizontal scale gives us the classes, and vertical scale gives us the cumulative frequency. You should remember cumulative frequency distribution table. I think we covered that last Tuesday. We went over 3 types of frequency distribution table. Yeah, the first one is the regular one and a grouped frequency distribution table. The second one is a relative frequency distribution table. And the third one is this one, cumulative frequency distribution table. And the frequency, since it's accumulating, the frequency, when you look at the cumulative frequency distribution table from top to the bottom, the frequency is accumulating, so it's getting bigger. That's the reason ogive is a line graph, kind of like a line graph, and it is increasing because the frequency is accumulating. Any question about ogive? I think ogive is from French, probably. Any question about that? Yeah, ogive is always going up because the vertical scale represents the cumulative frequency. Maybe there are cases it go flat a certain period of time, a certain range, but the general trend is going up. Well, let's go to the next one. Yeah. This graph, this here, we have 2 graphs next to each other. The one on left and the one on right. They are actually the same graph. However, the one on the left gives us an impression. What impression? The medicine, yes, kind of medicine, OXY counting, OxyContin. So the medicine, people who take those medicine, the percentage of people who took the medicine have the symptom of nausea. And this bar, the height of this bar, the smaller one, is the number of participants in the experiment who took placebo and have the symptom of nausea. So as you can see, the one on the left exaggerating the difference between the 2 bars. Okay, we're exaggerating the side effect, which is nausea, yeah, side effect of the medicine. When actually the difference between them is not that extreme. Yeah, twice. Yeah, the longer bar, the taller bar is twice of the shorter bar. But on the left, the graph on the left, the distance between the 2 bars is exaggerated. How did we make that happen? Yeah, let's look at it here. Look at the vertical scale, the starting point of the vertical scale. Yeah, people sometimes intentionally or unintentionally, yeah, distort the scale. Yeah, left starts at 10%. Exactly. Thank you, Dustin. Yeah. It does not start from 0%. So that makes the taller bar a lot taller than the shorter one. Okay, either intentionally or unintentionally. The graph on the left is deceptive. So when we look at a graph and understanding the data, understanding the statistical result, we need to pay attention to the scale, yeah, vertical scale or horizontal scale. Does that start from 0%? If not, you have to be critical, right? Yeah, apply your critical thinking, statistical thinking. Use your good judgment to see if the information, the impression actually exaggerating or distorting the real information here. And next one, 2 cigarettes. Both of them are 3-dimensional figure. Yeah, because you can see is a cylinder, right? It's a cylinder. So it's a 3-dimensional figure. The one on the left represents the year of 1970. In the year of 1970, 37% of US adults smoked. And then the one on the right says the proportion of US adults smoked in 2013, and the proportion or percentage is only 18%. Well, if we only look at the two numbers, 37% and 18%, yeah. In the 70s, yes, more people smoked, but the percentage is only a little bit more than twice of 18%, right? Twice of 18% is 36%, and 37% is a little bit double, twice of 18%. However, if you do not look at those data, if you do not have those information, you only have the two cigarettes, what would you feel? Would you feel that the smokers in the 70s only twice of the smokers of 2013? Because you will think about the volume, right? Volume is a three-dimensional concept. I believe the painter wants to do this because this length is half of this length, right? The longer cigarette, the length is twice of the shorter one. However, they use the painter uses three-dimensional figure to represent a one-dimensional concept, and that would give us an impression. What impression? 8 times. Yeah, in 70s, the proportion of the smokers is 8 times more than the smokers in 2013, because volume-wise, the bigger cigarette is 8 times of the smaller cigarette. You might wonder, how do you know it's 8 times? Because the height is twice. Height is twice and the radius is twice. You know the cylinder volume formula is pi r squared times h, right? And if you double the r and you have a square here, so you have 4 times, and you have h here, that is 8 times. Am I clear about that? This is also the one, yeah, the whole thing here is a deceptive graph. Does that make sense? When you work on your MATLAB math homework, you should see something like that. One type of deceptive graphs use 2 or 3 dimensional figure to describe a one-dimensional concept that must distort the information, the data. Okay, I'm gonna count to 3. 1, 2, 3. If nobody say anything, I'll just keep going. The next graph is a scatter plot. Scatter plot actually is the concept of the last section of chapter 2. Last section of chapter 2 is about scatter plot, correlation, and regression. In fact, regression is a very important and useful concept or tool, statistical tool that you can use. But I look at our MATLAB math assignments and the quizzes and tests. We don't really have anything about regression. Now I think I will just not cover it. And about the correlation, only a little bit of information is covered. So scatter plot is a good tool to show if there is a correlation between two variables. So a scatter plot, those are scatter plot. They are two-dimensional graphs, and you just see bunch of points. We know a point in a rectangular coordinate system, x, o, y, plane. A point is defined as an ordered number pair, right? A comma b or x comma y. And that gives us a way to study the relationship between two variables. The first component would be the values of the first variable, and second component would be the value for the second variable. And we use a scatter plot to see if there is a certain relationship between the two variables. Yeah. For example, this one, the horizontal scale, is the tar in the cigarettes. Actually, I don't remember what's this about. And the vertical scale is CO, monoxide carbon. Yeah, so as we can see, the two variables does have a kind of relationship. Since the pattern is linear, based on the graph, we can determine there is a linear correlation between the two variables. Since the trend is going up, we say there is a positive linear correlation between the two variables. The last one, as you can see, the linear correlation also very obvious between the two variables. The horizontal scale is the weight of vehicles, and the vertical scale is the vehicle's speed on the highway. Yeah, as you can see, when the weight is bigger, heavier, the speed goes down, right? Miles per, oh, not speed, I'm sorry, it's the mileage per gallon. Yeah, fuel efficiency. Yeah, that makes sense. When a car is very heavy, then the same gallon of gas can only drive shorter distance, right? Yeah, as you can see, also we have a linear correlation, but this time the linear trend is going down. So we say that there is a negative linear correlation between the two variables. Again, correlation does not represent causality. If we see a linear correlation between two variables, we cannot be certain, we cannot draw the conclusion that one variable causes the other. Two totally different things. And by the way, correlation could be any type of correlation. Doesn't have to be linear. It could be non-linear. For example, if you see something like that, two variables, this is a variable x, this is a variable y, and maybe the scatter plot look like that, right? Yeah, when that happens, we also say there is a correlation between the two variables. It's just not linear. In this case, it's a quadratic. Yeah, we do not really cover that. And in our book, also when you work on your homework, we have a method to measure the strength of the linear correlation between two variables. Okay, yeah. And what is the tool? What is the method to measure the strength of the linear correlation between two variables? Little r. What's the name of r? Linear correlation coefficient. Linear correlation coefficient. And the absolute value of r is less than or equal to 1. Okay? When the value very close to 1, very close to 1, we say the positive linear correlation is very strong, like 0.99 or even 0.980. When r is very close to -1, let's say this is -1, this is 1, this is 0. Yeah. And we have a table can tell you the critical value. They are symmetric. For any given sample size, we can find the critical value. When the R fall in the green region, and we say the linear correlation is very strong. When R fall in the purple region, we say the linear correlation is very weak or no correlation, no linear correlation. So it depends on the sample size as well. Okay. Anybody have any question about this chapter? Very quiet.
No.
Are we good with this?
Yes.
Okay, thank you, Melinda. Well, then let's start chapter 3 now.
It's thunder done.
Yeah, let's start chapter 3. The first section of chapter 3 is about central tendency. Yeah, central tendency of a data set is also called the center of a data set. So firstly, let's play a game. Yeah, we play the matching game. Just to use your common sense, your judgment. Let's see if we can get it done correctly. Okay. Yeah. So I have those. Numbers. Yeah, you help me to match them. So the first one, during the average lifetime, Americans' average time of kissing. What do you think? During the average lifetime, Americans average time of kissing, the lifetime. How long is that going to be? C? Okay, let's see what is C. 14 days, 2 weeks. That's correct. Very good. Perfect. Yeah, about 2 weeks kissing. Of course, not consecutive 2 weeks. 14 days scattered around the lifetime. Second one, the average number of friends for a Facebook user. Which one do you think? Take a wild guess. Mine's only 200. I only have shy 200 friends. Most of them I don't even talk. Okay, let's see what is E. Yeah, actually it is E. Okay, it is E. How do you know? Good judgment. Is F? It's not F. Not that much. Not that many. Yeah, it's E. Yeah. The average number of friends for a Facebook user is 338. You know what? This question is from probably 2021, a couple of years ago. Yeah, not very recent. Yeah, not very recent. Not updated. Okay, the next one, the average number of cars an American owns. How many cars a typical American owns the lifetime? Yeah, many people choose A. Let's see what is A. That's correct. 12 cars. I only have 2 cars so far. I'm using my second car. Next, the average number of times a 6-year-old laughs per day. 6-year-old laughs per day. How many times? A typical 6-year-old. Many people choose D. That's correct. You guys are awesome. You guys are awesome. Yeah. Next, the average number of hairs. The average number of hairs in the human eyebrow. Yeah, you would not answer 28. Yeah, the more we do, the less chance we messed up, right? Yeah. No 28. I bet it's more than 28. Okay, it's 550. Can you believe that? Eyebrow, 550. Average, typical. Of course, the last one is 28. What is the last? The average number of years in the lifespan of a citizen during the Roman Empire. Yeah, how long? Average longevity at that time. Probably Roman Empire is like 1600 years ago. Yeah, 1600 years ago, long time ago. Yeah, unfortunately, they don't have like a longevity like modern human beings. Yeah, only 28 years. Yeah, that's like a long long term. Yeah, very good, very good, very good. So how do we understand those data? Those numbers represent what is average or typical in a variety of situations. In statistics, such values are known as measures of center. Yeah. Sometimes the book says call that measures of central tendency or measures of center. It's the same thing, different ways to say it. Yeah. because they are generally located toward the center of a distribution. This section, we are going to cover 4 types of measures of center. The 4 measures of center are mean, median, mode, mid-range. Okay, you guys ready? Let's start it. The first one is mean. Mean here, I need to point out, we mean arithmetic mean. You might wonder, there's other types of mean? Yeah, there are geometric mean and harmonic mean, but we do not cover them. Yeah, in our book, when we do our homework, when we say mean, it refers to the arithmetic mean. Yeah, what is arithmetic mean? In real life, like in common life, when we say average, that is arithmetic mean. Yeah, mathematician or statistician will not call mean average. It's just normal people, like normal people, we use average. Sorry, that's a V. Average. Yeah, we actually means the same thing. Okay, we refer average. Yeah, refer to the same thing. For example, you made $20 yesterday, and you made $30 today. Then only consider those 2 days. How much do you make per day on average? Then you would do, what would you do? You would add 20 and 30 together and divide the sum 50 by 2, which gives you 25. So you would say, based on the data from yesterday and today, my average day, I make $25 per day, right? Yeah, I just come up with a random example. So you understand what I mean? That mean, arithmetic mean, simply means average, okay? This is the formula for computing sample mean. Yeah, we are talking about statistic, not parameter. You might remember the difference between the 2 concepts. Parameter is the numerical description of a population. A statistic is the numerical description of a sample. Yeah, so all the of center we learned today, and then on Thursday the measures of variation. We are talking about statistics, plural, about sample. We do not talk about the parameters about population. Okay, so the notation for sample mean is x bar. Yeah, little lowercase x, and then you put a bar above it. Yeah, that notation is the sample mean notation. And let me explain the formula. What does that mean? Apologize for that. This is my personal device. It's not the best. Yeah. To find the sample mean, we add this sigma, big sigma. This is called a sigma. This means the sum. This represents a summation. Sum of all the x in the data set or in the sample. Yeah, you can do I from 1 to n. Yeah, you add all the n values together and then you divide it by the size of the data set. Is that clear? Are you able to understand the formula here? So the formula gives us the process of finding sample mean. If we are given a sample, how do we find the mean? Yeah, arithmetic mean. Yeah, let's say the sample has n values. All we need to do is to add up the n values and then divide the sum by n. And the result would be the sample mean. Does that make sense? Does it make sense? Okay, let's see an example here. Do you guys have a calculator? The first example, The sample has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 values. So we say the sample size is 10. How do we find the mean? Oh, you don't have, Charlie? How about just for now, use the cell phone, use
You
the
you clicked off
calculator.
of it so we couldn't add up the numbers.
You what?
There we go.
Oh, yeah, you want to see it and you can add them up, right?
Yes.
Okay, very good. Yeah, add them up. Tell me what is the sum.
Is it 1830?
Do we agree, guys? I did not check yet. I need to find my calculator first.
Okay.
Do you guys agree? Let's see. Yeah, Dustin has the same thing. I would say this is correct, right? And then
Yes.
you divide the sum by 10. What do you have?
183?
Yeah, 183. 183. So 183 is the mean. Okay? 183 is the mean. Is that easy? I would say
Yes.
this is straightforward. Okay? Yeah, very straightforward. So this is how we calculate or compute sample mean if we are given the raw data set. If we are given the raw data set. For those that don't have a calculator, there's an app called the Calculator 84 that you can download. And then, okay, very good. Yeah. But you cannot use that for the test for sure. Cell phone is not allowed. You can do that when you're doing the homework. Okay, so the first example shows us how do we find sample mean when the raw data set is given. All we need to do is just add them up and then divide by the number of the data. Yeah, thank you, Lee. Yeah, I understand you. It's just for the homework. Very good. Thank you for the information. And the second example, we are not given the raw data set. Instead, the raw data set is organized. As this. Do you remember the name of the table? Yeah, we don't have a bunch of numbers like this, right? Yeah, when the number of values are long, many, when the sample size is very large, and is this way to display the data set probably not very practical. So we sometimes organize those data in the table. Yeah, use the frequency distribution table to organize it. So let's look at the table. Let's understand what's going on here. So the first column are the data values. They represent the stress readings. Yeah, seems like we have 11 different stress reading. If your stress reading is 0, that means you are carefree. If your stress reading is 10, that means you are extremely stressed. Yeah, you probably should take a vacation or something. Yeah. And so the second column, we have the frequencies corresponding to the participants' stress readings. So how do we understand that? Among the participants, you're gonna tell me how many of them, okay? Among the N participants, 2 of them are carefree. 1 of them has a level 1 stress reading. 3 of them has level 2 stress readings. 12 of them has a level 3 stress reading. 16 of them has a level 4. 18 of them has a level 5. 13 of the participants have a level 6. 31, this is the biggest number. 31 of people has a level 7. Yeah, 26 of the participants have a level 8. 15 of them have level 9, and 14 of them are extremely stressed. Okay, so that's how do we understand the frequency distribution table. Now let me show you how do we find mean when we do not have the raw data set. Instead, we have a frequency distribution table that represents the data set. The formula is sigma x times f and then divided by n. Yeah, let me explain what does that mean. The denominator is still the sample size. Okay, yeah, I'll show you how do we find it. Let's talk about the numerator. How do we find the numerator? This is how. First row, reading 0, yeah, x value is 0, multiplied by frequency, the corresponding frequency 2, plus the second value, which is 1, multiplied by its corresponding frequency, and next value is 2, 2 multiplied by its corresponding frequency 3, and then plus 3 times 12. I need more space for that. Yeah, and then plus 4 times 16. And you know how do I proceed, right? Plus 5 times 18, plus 6 times 13, plus 7 times 31. I know this is not something convenient, but you would have to do that because when you take the test, the software is not available. All you have is a calculator. And if we continue, 8 times 26, 9 times 15, 10 times 14. Do you see that, guys? Yeah, that's the numerator. Let's understand why, okay? Let's understand why. The numerator basically is the sum of all the values in the sample. For example, you have 12 threes, right? So instead of you write 3 plus 3 plus 3 plus 3 and so on plus 3. Instead of writing 12 threes added together, you write 3 times 12. Does that make sense? Yeah, that's how do we have the numerator like that. You might remember from algebra, you learn PEMDAS. PEMDAS tells us we have to take care of multiplications before additions. Okay, so when you manually calculate the numerator, you wanna find those products first. Okay? And then do the addition, and then add them all together. Am I clear about that? So follow the correct order. Yeah. So the numerator gives us the sum of all the values in the data set. Now we are taking average, right? So now we are going to divide the sum by the number of values in the sample. Anybody can tell me how many values do we have in the sample? How do we know that? I would like you to help me with that. How do we know how many numbers, how many values in the data set? How many data values? How many data values? Let's see if you have the same answer. We have 151. Add them together, 10 for the problem, I think. Hold on. Yeah, add a frequency, exactly. Not 10. The previous example 1 is 10, but this one's a lot more. Yeah. Add the frequencies together. Add those numbers together. What do you have? Is 151, guys? It is time to practice using calculator. So 2 plus 3, that is 6. 6 plus 12 is 18. 18 plus 16 is 34. 34 plus 18. And then plus 44. Plus 26. Plus 29. Yeah, I got 151. Awesome. Very good. Perfect. And who has the numerator? Who has the numerator though? Numerator is 10. No, I don't think so. Way more than that. Way more than that. Okay, let's spend time to do that. Since, as I pointed out here, this section, we do not recommend use StatCrunch or Excel or any software. It's a way to practice how do you use calculator and how do you understand the formulas. Yeah, let's see anyone has the result. Yeah, not 10. Yeah. Okay, let me do it. So let me do the multiplication first, okay? So that is 0, that is 1, that is 6, that is 36, that is 64, that is 90, and that is 72. Yeah, 13 times 6. Hold on, no. 13 times 6. 13 times 6.
78.
78, exactly. And this one is 217, right? Am I right? And this one is 8 times 26. Let's see, what is it? 208. And 15 times 9, 135. Am I right? Double check. 9. Yeah. And this is 140. Yeah, if you actually do that, it's not very intimidating. It's the time you're hesitating. I don't want to do that. Make it harder. If you actually is doing it, it won't take too much time. And then I'm going to add all the numbers on the top together. So I have 7, 36. That's 43. 43 plus 64 plus 168 plus 217 plus 208 plus 275. I got 975. Anybody has the same value with me for the numerator? Oh yeah, thank you, Dustin and Lee. Am I pronouncing your name right? Lei or Lee?
It's Leah.
Leah. Okay, thank you for correcting me. Leah. Okay, I'll
No
learn.
problem. That's no problem.
Yeah. And we're gonna divide the sum by the sample size divided by 151. Yeah, you need to figure out what technology. Well, you only have a calculator available during the test. You need to figure out what kind of calculator you are going to bring with you, right? Yeah, this means approximately equal to. If we round it, I'm going to round it to 1 decimal place, 66.5. So the center of this data set is 6.5. Well, so 6.5 actually is not even a level. We can round it up to 7, right? Or between 6 and 7. Yeah. So you can see averagely speaking, people have like a level 7 stress reading. Yeah, as you can see, it seems a lot, but when you actually are doing it, it's not that horrible. Just be patient. You don't have many problem on the test, and you have many minutes, so you definitely have time to be careful you have the time to double check your values and make sure the value is correct. All right. So example 1, I shows you how do we find the mean if the raw data set is given. Example 2, I show you how do we find the mean if the raw data set is not given, but the frequency distribution table is given. Next, example 3. What if the raw data set is not given and we do not have a regular or basic frequency distribution table? Instead, we have a grouped frequency distribution table. You know what? If we only have a grouped frequency distribution table like this one, you remember the grouped frequency distribution table have 2 columns, right? But you will see something like that. I got this from our MyLab Math homework. It gives you 2 rows, so the table go by horizontal. It's the same thing. What happened is the first class is from 40 to 44. Second class, 45 to 49. Third class, 50 to 54. Next class, 55 to 59. Last class, 60 to 64. And among the values in the sample, 3 of them fall in the first class. That means 3 values fall between 40 and 44. Again, this is not 40 minus 44, okay? This represents a range from 40 to 44. And then we have 4 values fall between 45 and 49, 9 values between 50 to 54, 6 values 55 to 59, 2 values between 60 and 64. Then are we able to find the mean? Let's see if we have any questions. I missed how she put 151 at the bottom. Good question. How? How do we find 151? Where do we get that number? 151 is the total number of values in the data set. In other words, 151 is the sample size of the sample of the data set. Yeah. How do we get it? We add all those frequencies together. Okay. We add all those frequencies together. We got the values, total number of values. Yeah, denominator. Okay, you got it. Perfect. Yeah. Add the frequency. Did we not use the 183 from the? Where is the 183 from the top?
When we first started the
That's the first question.
Okay.
Okay, let me draw the line. Yeah, let me draw the line. That's example 1.
Okay.
And then I start example 2. Okay? And
Okay.
now actually I'm starting example 3, you know? I showed you in 3 different situations how do we find the mean, right? And you know what? If you only have a grouped frequency distribution table like that, there's no way to find the actual mean. But we can estimate the mean. We can estimate the mean. Let me show you how. Okay? Yeah, there's no way to find the exact mean value. Why? Because we only have a distribution. Yeah, we know 3 values fall between 40 to 44, but we don't know what the 3 values exactly equal to, right? Yeah, we know 9 values fall between 50 to 54, but we don't know the values, exact values of the 9 values fall between 50 to 54, right? So there's not possible to find the mean. However, we can estimate, we can approximate. So if you see something like that in your MyLab Math homework, this is what we do, okay? Firstly, you need to find midpoints for each class. You remember that? That's last Tuesday, yeah. So the first class, lower limit is 40, upper limit is 44. What is the midpoint? 40 plus 44, 84, 84 divided by 2. Yeah, midpoint is 42. Awesome. Thank you, guys. Yeah. Oops. 42, yeah, exactly. Then you should know how do we find other middle point, right? You know, there's a easier way. Can you tell me what's the class width? Class width. This time we're gonna go horizontal. You know, class width is defined as the distance between two consecutive lower limits, right? Yeah, exactly. It's not 4, it's 5. Perfect. It is 5. Awesome. You guys are great. Yeah, 5. So we have an easier way. Once we have the smallest, and once we have the middle point for the first class, we are able to add a 5, add a 5, add a 5 to get all other middle point. So the second class middle point would be 47. If you don't believe that, you try. 45 plus 49 is 94. 94 divided by 2 is still 47. Yeah, just a faster way to find out other middle point. Plus another 5, 52, right? Plus another 5, 57. Yeah, plus another 5 is 62. Yeah, you can see 60 plus 64 is 124. Divided by 2, have 62. Yeah. So if we are given a grouped frequency distribution table and we are going to find the mean or estimating the mean, this is what we do. We firstly find those middle points, and then we are going to multiply those middle points with their corresponding frequency. The first middle point is 42, multiplied by the frequency, which is 3, plus second middle point of 47 multiplied by its corresponding frequency, which is 4, and then plus next middle point times frequency 9, next middle point of 57 times frequency 6, next middle point of 62 times frequency 2. Very similar with earlier, but it's different because we are only approximating. We don't really have the values to, to find the actual value. And the denominator same, always is the sample size. How do we find the sample size here? Add up those frequencies. You know what? Sometimes you need to read the question. Sometimes the problem gives you the sample size up front, and you really don't have to make the effort to calculate the frequency. All right, guys, ready? Yeah, please do that with me. Yeah. So I'm gonna do it by steps. We're going to do the multiplication first. Yeah, this one is 126, and that is 188. Double check. Yeah. And that one is 52 times 9, 468. Yep. And this one is 57 times 6. And that one is 124. And the denominator, I can just add them up, right? It's 10, 13, 15, 15 plus 9, 24. And now I'm going to add up those numerators. 126 plus 188 plus 468 plus 342 plus 124, and that gives me 1,248 divided by 24. What is my mean? My mean is 52. Let's see you guys' message. 1248. Yeah, that's my numerator. Perfect. Thank you, Dustin. Yeah, exactly. Same with mine. Yeah, if you time yourself, it really doesn't take much time. And this is the requirement from this course. You have to know how to manually calculate that. All right, summarize, just a little summarize here, a shorter summarize here. What we covered 3 examples, right? 3 examples. Yeah, the 3 examples shows you how do we, the first one, how do we calculate the mean when we are given the raw data set. Add them up and then divide by the number of the values. And second example shows you how do we find the mean if the raw data set is organized in a frequency distribution table. Okay, yeah, you use the values times its corresponding frequency and add them up and then divide by the sample size. And the third example shows you if you are given only a grouped frequency distribution table, how do you estimate the frequency? How do you estimate the sample mean? All right, guys. Yeah, we need to keep going. I feel like every time we do finish what we need to finish. Yeah, let's keep going. The second measure of center is called a median. It's called a median. What's the definition of median? Median is the middle of an ordered data set. Yeah, let me show you an example, and right away you would know how to find the median. Okay. Let me copy this and then paste. This time we are going to use this example to find the median. We're not finding mean anymore, we're finding median. Very important, when we find the median, we have to sort the data. Normally we go ascending order, okay? Yeah, sometimes the data set is given in the order. Yeah, actually when I'm looking at this one, this data set is actually in the descending order. What do you think? 240, 200. Yeah, it's actually already sorted in the descending order. It really doesn't matter. Descending order or ascending order, both would work if the goal here is to find the median. So make sure it's sorted. And then let me show you how do I find the median. Remember, median is the middle of the data set, right? Okay, this is how do you manually do that. Once you have the data set sorted, you cross out the biggest, the smallest, and the biggest, the smallest, the biggest, the smallest, the biggest, the smallest, and sometimes we have a one value in the middle, and one value in the middle would be the median. But sometimes we have two values in the middle. Like in this case, we have two values in the middle, right? And what do? We are going to take the average of the two values in the middle. Yeah, since in this case they are the same, of course the average is the same as well. You see what I'm talking about?
Yes.
Okay, so I'm gonna write some data set and let you to try, okay? Yeah, for example, if you have 0, 1, 3, 7, 4, 2, 0, 1, 2, 3, 4, 5, 6, 7. So that is a 7 values. Yeah, this is a practice number 1. And practice number 2, I'm gonna give you a data set with an even number of values. So let's try 10, 14, 8, 13, 2, 3, 4, 5, 11, 1, 2, 3, 4, 5, 6. Yeah. Okay, I'm gonna give you a little time and try the method I just shown you for the median. Yeah. By the way, this is 2 and 0, not 20. Okay. Yeah, not 20. For the first one is 2. Median is 2. A little bit. Let me sort it first. Yeah. Let's sort it first. 0, 0, 1, 2, 3, 4, 7. Right? Yeah. If I sort it, I have a 0, 0, 1, 2, 3, 4, 7. And then if I use my technique, cross out, cross out, cross out. You're right. It is 2. Awesome. Yeah. So if you only have one value left in the middle, then that value is the median. Yeah. What if you have two values left, like the second problem? Yeah, firstly, don't forget to sort it. Okay, I know it's annoying, but you would have to do that. Yeah, so we sorted 5, 8, 10, 11, 13, 14. Yeah, and then we do the technique. Cross out, and we have two values in the middle. Which one is the mean? None of them. We have to take the average. Okay, 10 plus 11 divided by 2. Yeah, 10 plus 11 is 21 divided by 2. We have 10.5. 10.5 is the median. So two different cases. Yeah, the first case, the median, the sample size is odd. If the sample size is odd, like a 7, 9, yes, 1, 3, 5, 7, 9, 11, 13, those are odd number. If the sample size is odd, then you would end up with one value in the middle. Then that one value in the middle would be the median. So if the sample size is even, and you use this method, you will end up with two values in the middle. Then you would have to take the average of the two values to find the median. Okay, so we are talking about median right here. We are talking about median here. Yeah, 10.5. Yeah, you are right, Miranda. 10.5, sorry. Yeah, means mine is 10.5 as well. Oh, okay. Very good, very good. So median is pretty not very difficult to find. Yeah, and even manually is not difficult. And I already look at your homework. You would not have something like that, like many values, and you will not have something like that to find the median either. So this formula, what is this formula? This formula actually tells you which position of your median locates. If you sort the data, then the median should be the n plus 1 all over 2 position. Okay, yeah, but you don't really need it because I already look at your homework and the quiz and test. They're just a simple question about finding median. Yeah, and you might wonder, if we have a mean already, why do we need a median? When do we use mean? When do we use median? Yeah, so those two measures of center, they have their own advantages and disadvantages. The advantage of a median is not sensitive to outliers. It's not sensitive to extreme values. Outliers are defined as a value or values in the data set that is far away, a lot bigger or far less than majority of the values. It's different, yeah. A lot bigger or a lot smaller. By itself, it's called outlier. Outliers and extreme values, they mean the same thing. So median is not sensitive to outliers. That's a good feature about the median. So sometimes we would use median rather than mean to find the center of a data set. For example, if you are going to a department of a company, you're going to work for a department of a company. They have 4 employees and a manager. And the employee's salary, let's say this one is 50K, 50K, yeah, annual salary has to be 50K. And this one is 51K, and the other person is 49K, the other person is 47K, and the manager 200K. Okay, yeah. So you wanna know, if I go there, how much is my salary? You wanna estimate, right? And you wanna know, so how do you estimate? You wanna probably take the find the center of the data set, right? So if you use mean, you will see the mean is gonna be distorted, twisted, because this is the outlier. The manager's salary is way more than all other employees. If you are hired as an employee and you use the mean for your estimated salary, you will be disappointed because the mean will be bigger than the actual you are expecting. And so in this case, the median would be a better measure of center. because the median will not be sensitive to the outlier. All that matters is the number in the middle, right? Which value in the middle. So median would be a better measure of a center. Does that make sense, guys? So it depends on your data set. If you have outliers, you want to use median. You do not want the outliers or extreme values to distort your center. Yeah, of course, mean is a good measure of center as well. It really depends on the situation. Yeah, it uses all the values in the data set. Sometimes it's good. Really depends on your need. So that's a difference between the two measures of centers. Any question about that?
No.
Okay, so mean and median, okay? Those are two. The next measure of center is called a mode, M-O-D-E. Definition of mode. Mode of a data set is defined as a value in the data set that has the largest frequency. In other words, mode of a data set is the value appears the most of the times. Okay, the most of times. Let me, so firstly, I want you to remember or write down the definition. It's really all about definition. And then I'm going to give you some examples and then we practice. Mode, again, refers to a value in the data set. Which value? The value with the biggest frequency. For example, here, you know, the reading, stress reading problem, example 2 we had earlier. Which value has the biggest frequency? Which value has the biggest frequency?
Number 7.
Yeah, exactly. What's its frequency? Perfect. Yeah. So what's the mode of this data set? Is the mode 7 or the mode is 31?
The mode would be 7 as well.
Perfect. It's not 31. Okay, 31 is the frequency. But yeah, the mode is a value, one of the values with the biggest frequency. Very good, very good. Yeah. So let me give you another example. What's the mode? Zero and 1. Awesome. It has two modes, right? Yeah. Yeah, you are right. 1 is a mode, but 0 is also a mode. 0, 1. When you go to MATLAB Math, you would know the question would ask you, use a comma to separate the mode if you have more than one. And when a data set has two modes, we call the data set what? Bimodal. Bimodal. Okay, so let me give you another example. What about this one? The one we had earlier. This one. 240, 200, this one. What's the mode? Yeah, awesome, exactly, yeah. And let me give you another example. What happened to this number 2? The data set number 2. What's the mode? 10, 14, 8, 13, 5, 11. What's the mode?
It doesn't have one, correct?
You're right. No mode. Yeah, you said none. Yeah, we say no mode. No mode. Exactly. Very good. Yeah. If all the values have the same frequency, then no mode. Nothing stands out. If two values have the same the biggest frequency, bimodal. We also have a multimodal, but we don't really see that kind of question. Yeah. Okay, so do you have a question about the mode? Why do we need to use mode? Why do we need to use mode? Isn't mean and meaning already enough for us to find the center? Huh? So what if your data set, what if your data, your data set are qualitative or categorical? For example, your data, the data you collect are people's eye colors, brown, green, blue, hazel, you know, those information. How do you take a mean? Can we add them up and divide by this? No, we can't, right? How do we find the median? We cannot even order them, so we cannot do anything. So how do we find in that case we need a mode, okay? Yeah, so qualitative or monomial, not monomial, sorry, nominal. You might remember the 4 levels of measurement, right? Nominal. Yeah, it is nominal, and we need a mode. The very, very common example about using mode is voting. For example, we have 4 candidates, A, B, C, D. And let's vote. Yeah, the result shows A has 4 votes, B has 9 votes, C has 3 votes, D has 1 vote. Which candidate has the biggest frequency? That actually is the frequency, right? Then B wins because that's the mode, right? Yeah, that's the mode. That means majority of people. That means people like B to be the leader. They voted for B. More people voted for B. Yeah, do you see what I'm talking about? That's the usefulness or application of this type of measure of center mode, not numerical. Yeah, sorry, it could be numerical. It could be numerical, but when the data are not numerical, they are nominal. Then we would only could use mode. Cannot use median or mean, right? Yeah. Okay. Any question about mode?
No.
Okay. So the last one, the last measure of center is called a mid-range. Mid-range. Mid-range is a measure of center. We must differentiate between those two concepts. On Thursday, we are going to talk about range. And today we have a concept mid-range. And those two concepts, name-wise is similar, formula-wise is similar as well. Yeah, let me show you what's the formula for mid-range. Mid-range of a data set is the maximum value add the minimum value and divide by 2. In other words, mid-range is the average of the maximum and the minimum. And range instead is defined as the maximum minus minimum. Yeah, they both use maximum and minimum, the two extreme values. Yeah, the two extreme values, but they are very different. The important thing is we know the difference. They sound similar too. Mid-range is a measure of center, so we learned today. Range is a measure of variation. We are going to learn on Thursday. That's the first difference. Second difference is the definition, is the formula, right? Yeah, mid-range is the average of the maximum and the minimum. And range cares about the range, the ballpark from the smallest to the biggest, right? Yeah, the range, it describes the variation of the data set. So they use for different purposes. So do not mess them up. Okay, mid-range is the last type of measure of center we learned today. Yeah, it is defined as the average of the maximum and the minimum. Okay, yeah, for example, it's easy to remember this, right? Okay, for example, this question, example 1, this data set. Can you help me to find the mid-range? Do we have to find the minimum and the maximum first? Maximum 240, minimum 165. Add them up and divide by 2. Right? So that is 120 plus 82.5. Do you have 202.5? 202.5. Yeah, very good. Okay, perfect. Yeah, I don't know how do you get that number. You add, please don't minus. It's very common for some reason. People use the maximum minus minimum divided by 2. My understanding is they probably messed up the 2 concepts and 2 formulas. That's the reason up front I pointed out there are totally two different concepts serve for different purposes. Yeah, try again. Add the maximum and the minimum. Okay, yeah, that's fine. Type the add the maximum and the minimum and divide by 2. Is the mid-range a good measure of center though? Let's think about that. Is mid-range a good measure of center? Well, it asks you specifically to find the mid-range or range. Yeah, of course, of course. That's a very good question. Of course. Those two words are different. If they are going to ask you for the mid-range, they will just ask you mid-range. If they need you to find a range, they will tell you range. My point here is do not confuse one with the other because they are pretty similar. A common mistake all my students used to make is to, when they do the mid-range, they use maximum to minus minimum and divide by 2. I don't know why, how does that come up I don't know why they do that, but it's wrong, right? The mid-range is the maximum plus minimum all over 2, divided by 2. So please don't confuse that with the range. Am I clear about the difference between the two concepts?
Yes.
Okay. Yeah, earlier I asked, let's judge. Yeah, let's be judgmental here. Let's think about, is mid-range a good measure of center? Why do we need it? We already have mean, we already have median, we already have mode. Why do we need the fourth measure of center, mid-range? Okay, think about if our data, if you are doing research, the data you collect are temperature. Yeah, the data you concern is temperature. Yeah, temperature. Then, for example, the temperature of today, right? How are you gonna find the mean? How are you gonna find the median? How are you gonna find the mode? Because those values are continuous. Yeah, your temperature, the temperature is continuous, right? It's not discrete that you can list them here and then you are able to add them up because you only have finite number of values if your data set is discrete. But what if your data is continuous? Yeah, the value could be any value in an interval, and then you are not be able to find the mean because you are not able to add them up. You have infinitely many values, right? You are not able to order them and find the value in the middle either. Yeah. So mid-range in this case is useful. Okay, yeah, one way to find the average is take the maximum temperature, the highest temperature of the day, and the minimum temperature of the day, and add them up and divide it 2. And you can use that as a center. Am I clear about that? They serve different purpose, depends on your research, your type of data. Yeah, I have those information included in my notes. Yeah. Any questions? Well, I'm taking picture of the attendance.
No.
Yeah, so we learned the 4 types of measures of center. You use different measure of center for different research. Yeah, depends on the data you collect. The important thing is you know the concept and you know how to calculate. I look at your homework. I think the challenging part is grouped, like the frequency distribution table and the group the frequency distribution table. Yeah, in those cases, how do you find the mean? I already show you, right? Yeah, if it's grouped frequency distribution table, remember to find the midpoint for all the classes first, and then use the midpoints to multiply their corresponding frequencies. Yeah, and then add all those products together, and then divide by the number of the values in the sample, and you will have the sample size. All right, guys, and that's everything for today. I'm very happy today we finished everything. Then on Thursday, we can start section 3.2, learn the measures of variation. Okay, that's it.
Thank you very much.
No problem. If you have any question, feel free to email me. Thank you for coming. You guys have a great night.